Welcome back. Now, the last few videos we talked about enhanced input and how to convert input mechanics from the old way to the new enhanced input system. In this video, we're going to convert another project to the enhanced input system, and this one contains a few more types of input. This character is from my new Unreal Engine 5 Ultimate Game Developer course. And the project I have here has several things going on. The character can move around. They can press a key to equip a weapon and pick it up. They can put the weapon on their back. They can take it back off. They can attack with the left mouse button, and the right mouse button is a dodge ability, which uses up stamina. Now, these actions also result in other types of gameplay mechanics, such as combat and eliminating enemies in the world and things like that. So we have quite a few inputs linked up to this character and all done with axis and action mapping. So we're going to learn how to get directional input like this into the enhanced input system, as well as other actions like attacks, equipping weapons, and so on. So the first thing we need is to make sure we have enhanced input enabled. And this is a 5.1 project. We see Unreal Engine version 5.1, which means enhanced input is already enabled. If we search plugins for enhanced input, we'll see that it's checked. We have access to the enhanced input system. But all of the input so far in this project is done the old way. If I open my project settings and go to input, I see that I have some action mappings and some axis mappings. Now, depending on where you are in the course, you won't have all of these yet, but we'll go through all of them one at a time to show you how we can get this converted into using enhanced input. So we'll start with movement. Notice I have some axis mappings. I have move forward and I have move right. Now, move forward is mapped to W and S as well as the up and down keys. And S and down both have a scale of -1 to scale that input so we can move backward. And move right has D and A for left and right. And it looks like this should be left and right actually. So we might as well go ahead and fix that by selecting right for the one with a scale of 1 and left for the one with a scale of -1. So now D and right would result in right movement and A and left would result in left movement. Now this isn't that important because we're about to ditch all this and go into the advanced input system for our inputs. But before we do that, we'll first go over how these work. So I'm going to open up my character class. It's called /character. Now you're going to see more things here than you might have depending on where you are in the course, or if you're just watching this video straight from YouTube, you might have a completely different class with its own movement input. But movement in this class works with the move forward and move right functions, and these are bound to those axis mappings with the same name. So if I go to set up player input component, I can see that move forward and move right are both bound to their respective axis mappings. So we'll first work on converting these into using enhanced input in the new way. And we've seen in the previous videos that we need to add enhanced input to our build file so we have access to that module. So I'm going to go into source / that's my project name, and find my build.cs file. And in addition to all the other modules I have in here, I'm going to add enhanced input. And I'll go ahead and save and close out of both the editor and Visual Studio and regenerate project files, deleting saved, intermediate, and binaries. So deleting those folders, I can generate Visual Studio project files and open up my U project so I can rebuild the / module. And I can also open my Visual Studio solution. And now that I have access to enhanced input, I can use those classes. So I'm going to close my build.cs file and go back to /character. So now that we're ready to start using enhanced input, we're going to need some input actions and an input mapping context for my character. And since we're going to work on movement, I'm going to make a move input action, similar to how we made a move input action for the bird in previous videos. So in my characters folder, I'm going to make a new folder and call this input. And I'll open that and make a new input action. So I'm going to right click, select input, choose input action, and I'm going to name this IA underscore, and we'll just call this movement since we already made a move input action for the bird. Now that's okay if we have different input actions with the same name in different folders, but I'm going to call this movement just to be different. And we can open movement, and its value type is bool by default, but we're going to want at least an axis 2D. I'm going to use axis 2D for movement so we can move in 2 dimensions, forward and backward and left and right. Now we also need an input mapping context, and we can add our new IA movement to that context. So we can right click, go to input and select input mapping context. And I'm going to call this IMC underscore slash because that's the character I plan on using this with. So I can open this up and we can add a new mapping to this by clicking plus, expanding mappings, and I can search for my IA movement. I'm going to go ahead and select that. Now we have to remember that IA movement is a 2-dimensional input action. It takes an X and a Y. And if we add a single key, then by default that key is going to fill in the X for that 2-dimensional vector. That means we're going to need to at least modify it if we want to press a key and fill in the Y for the 2-dimensional vector. I'd like to use the X for left and right movement and the Y for forward and backward movement. So left and right is simple. I'd like to map my D and A keys and perhaps even the left and right arrow keys. So I can click this little keyboard icon and press D, and I don't really need any modifiers for D because if I press the D key, then I want the X component of my IA movement input action to be 1, and if I'm not pressing it, I want it to be 0, and that's the default behavior. Now I can add another key to this input action and click the icon and press A. Now this will be for when I'm moving to the left, and I'm going to want that X component to provide me with a value of -1, which means I'm going to need a negation modifier. So I'm going to click plus under modifiers and select negate. And we know that negate will negate X, Y, and Z, but in this case, it doesn't matter that we leave these all checked because a single key is only a single value. It's not 2-dimensional, and as we've learned, by default, a single key will fill in the X of a 2-dimensional input action. So the negate is all we need for the A. So that takes care of D and A. Now, what about moving forward and backward? The W and S keys. Well, let's click plus, and we'll click the icon and press W. And for the W key, I want to fill in the Y component of our 2-dimensional vector in this input action. To do that, we have to swizzle. That's a type of modifier. So we can add a new modifier, open the dropdown, and here it is. It's called Swizzle Input Axis Values. And if I click on that and expand the index, we see the order changes here. We're changing this input action key mapping so that it fills in Y first. So we can leave that at its default. And the result of this is when we press W, triggering this input action means we'll get a value of +1 in the Y component of the 2D vector in this input action. Now we want to move backward with the S key. So I'm going to add another key and click the icon and hit S. And for this one, we need to do 2 things. We want to swizzle so the S input data goes into the Y component of the 2D vector. And we also want to negate so it's negative. So pressing S provides us with an input data value of -1. So we'll go ahead and add a modifier and choose Swizzle Input Axis Values. This will ensure that pressing the S key will give us a value of 1 in the Y component of this 2D input action. But we also want to negate. So we'll add a second modifier and choose negate. Now we could do the same exact thing for the left, right, up, and down keys, but it's the same process. So I'll leave that to you as an optional challenge if you want to use the arrow keys as well as WASD. I'm okay with just WASD. So now that we have an input action and it's added to our input mapping context, we need to set this up in C++ so that my character can use this input mapping context. Now, setting up some of this is review. If you've watched the previous videos, we know that we're going to need a variable for our input mapping context, as well as variables for each input action that we want to add to our local player. So I'm going to do everything up here under begin play in the protected section. I first need a U input mapping context variable. And for that reason, I'm going to forward declare that type up here with my other forward declarations. So forward declaring U input mapping context. And I'm also going to need variables for each of my input actions. And those are of type U input action. So I'm going to go ahead and forward declare U input action as well. And now I can add my input mapping context variable. So it's a U input mapping context. And I'm going to call this /context. And we're going to set this from the blueprint. So I'm going to give it a U property with edit anywhere. Now I don't see an immediate need to expose it to the event graph, so I'm not going to give it blueprint read only or anything, but I will give it a category of input. Now I have a new input action, so I'm going to add a variable for this, and we'll set that in blueprints as well to our new asset we created. So it's going to be a U input action, and this is for movement. I'm going to call it movement action. And it'll get the same U property because we plan on setting this in the details panel. Now we need to add our input mapping context to the character, and we're going to do that in begin play. So we'll go to the character's CPP file and search for begin play, and we'll just do it right here. Now again, if you're taking the course and you're early on in the course, don't worry about any of the other code. You'll add that code later in the course when you get to that point. We're just talking about movement for now. So to add the input mapping context, we need to access the enhanced input local player subsystem. And we've seen in previous videos when we took a look at the third person template that we need these three includes: component/input component, enhanced input component, and enhanced input subsystems. So I'm going to add those includes right here in my character class at the top. So right here, we'll go ahead and separate those with a line there. So back to begin play, we first need our player controller, and we need our enhanced input local player subsystem. We did all this already a couple times. Here's the third person template project where we're doing it here. I'm going to simply copy these. This is review at this point, so I'm going to paste it here. The only difference is I'm calling add mapping context to add our input mapping context using the subsystem, but our mapping context is called /context. So that's what I'm going to pass in here. And just to remind you, we're declaring a local variable in the if statement, so it's only in this statement's scope. Same with our player controller, it's only in this outer if statement's scope. And we're calling get subsystem from the uLocalPlayer class, specifying the enhanced input local player subsystem, and we have to pass in the local player, which we got from player controller. From there, we can add the mapping context, specifying the context we want to add. And we do need to set this in the blueprint, so we can't forget that before play testing. But after these lines, we now have our input mapping context added, and all we need to do is bind some functions to our input actions. We only have one input action so far. It's called movement action. So we're going to want a function to bind to that. So we can make that function here. It's going to be a void function, and we'll call it move. Now we've seen that this move function needs to take an input if it wants to receive input action values. And that input is of type const f input action value reference, and we'll call it value. And we've also seen in previous videos that we need to include the type input action value.h if we want to use that struct, as we can't forward declare a non-pointer variable. So we're going to include that up at the top above the generated.h file. And now we have a function callback that we can bind to our input action. So we'll create a function definition for it, and then we can go about binding this to our movement action, and we do that in setup player input component. So we'll find that, and we'll be replacing move forward and move right with our new move function. So the first thing we need to do is take our player input component and cast it to an enhanced input component. We've seen that we needed to do that in the previous videos, and we do it this way by using cast, or in this case cast checked, to U enhanced input component. So I'm going to copy the interior of this if statement and make a new if statement declaring an enhanced input component local variable. And we can use this to bind our move function to our new input action, which we called movement action. So let's do it. We'll take enhanced input component and call bind action, first passing in our input action, which is called movement action. We also choose an E trigger event. We want to call this function when the input action is triggered. We have a user object, which will be this, and we have a callback function, which will be the address of the fully qualified move function. So it'll be a /character in my case, move. So now we have our function bound, and if that input action is triggered, then our move function will work. So we just need to decide what to do in move. Let's go ahead and find that function. And the first thing we can do is get the value of the input action value. So we can take value and call get using the template type corresponding to this input action, and this is a two-dimensional vector. So we'll use f vector 2D. And we can store this in a const local f vector 2D. So we're going to say const f vector 2D, and we'll call this simply movement vector and initialize it. And we can now get the x and y values. And the x and y values will depend on what keys we're pressing. We set it up with the right modifiers so that if we press W, then the y component of this f vector 2D will be 1. If we press S, it'll be -1. If we press D, the x component will be 1. And if we press A, the x component will be -1. Now, it doesn't really matter what we put inside this function at this point. We can choose whatever we want. Earlier in the course, we simply get the forward vector of the character and move the character forward. Later on, we do something more complex when we learn about rotation matrices. We get the forward direction of the controller and move in the direction we're facing. So depending on where you are in the course, you can just use the logic that we added to move forward, which would be basically to make a const f vector called forward and initialize it with get actor forward vector, and then simply call add movement input, passing in that forward vector and then a scale value. In this case, because we're moving forward, we want to scale this by the y component of the movement vector, because that's how we set it up in the input mapping context. Pressing W and S will fill in that y component, and it'll be positive or negative depending on whether it's W or S. So add movement input can be scaled by movement vector dot y. Now here's the cool thing. We can also take care of moving to the right if we want to do that by making a const f vector and calling it right, and we can call get actor right vector. And from here, we can call add movement input, passing in right, and scaling by movement vector. And this time we want the x value, because that will be positive or -1, depending on whether we're pressing D or A. So this will move us according to our actual character's forward and right vectors. It won't matter which direction we're looking in. All that matters is which direction the character is facing. So this is the first implementation that we do in the course. Now, later in the course, we get a little more complex by finding out our controller's direction. So once you get to that point in the course, you can come back to this video and see how we do it here. We would make a const F rotator called rotation, and we'll get our controller and call get control rotation. And you learn all about what controllers are and how they have rotation in the course. We also want to only use the yaw for the controller's rotation. We don't want the pitch or the roll, so we can make a const F rotator called yaw rotation and initialize it with 0 for the pitch, rotation.yaw for the yaw, and 0 for the roll. So we're zeroing out pitch and roll, we just have the yaw. Now we want the forward direction corresponding to the controller's rotation. And in the course we learn about what F rotation matrix is, how rotation matrices can find a vector corresponding to a rotation, and we do it this way. We make a const F vector called forward direction, and we initialize it using F rotation matrix. So we create one of those, passing in yaw rotation. So we have a rotation matrix corresponding to yaw rotation, and from the rotation matrix we call get unit axis, not axes, but axis, passing in E axis X. So the result of this is the forward vector corresponding to the direction our controller is pointing in. And from there, we can simply call add movement input. And we'll pass in forward direction, and we want to scale this by our movement vector. And in this case, we want the Y component of that, as we'll be pressing W and S to move forward. And we'll do the same thing to move right. We can make a const F vector called right direction. And this will be the same thing, F rotation matrix, yaw rotation. We'll use that, call get unit axis, but this time we want E axis Y. That'll get us the right vector for our controller, and we can call add movement input, passing in the right direction vector, and we'll scale this by our movement vector, but this time we want the X, as we'll be pressing A and D, and those will fill in the X component of our input action. So this is how we can have directional movement for our character. Now let's go back to project settings and input and take a look at those axis mappings again. We took care of forward and move right, and we only needed a single input action and a single callback function to handle both of them. Now we can handle turn and look up, and this will be handled the same way that we handled it for the bird in previous videos. So we'll need a look input action. I'll go ahead and make a new input action, right-click input, input action, and I'll call this IA, and I'll just call it looking, so it's not the same as the other IA look we made in earlier videos. And I'll go ahead and open it up, and this one can be value type axis 2D, just like we did before. And we need to add this to the IMC/input mapping context. So we'll add a new mapping, we'll select from the dropdown IA looking, and for the input type, we'll go to mouse and choose mouse XY 2D axis. And if we don't want inverted behavior, we can negate the Y component. So we can add a modifier, click the dropdown and add negate, and expand that and only have Y checked. So that way we're not negating the X, but we will negate the Y. And if we want to link this up to a C++ function, we're going to need an input action variable in our character. So we'll go back to /character, and along with the movement action, we'll add a new input action, and we'll call this look action. And we'll also need a new callback. We'll make this a void function called look. And it'll have the same input, a const F input action value reference. So we'll go ahead and make a function definition for look. And we'll implement this in a second, but first we have to take care of binding it to our input action, and that's in setup player input component. So we'll do that in here. So it's basically the same thing as this line. The only difference is that instead of movement action, we're now using our new look action input action. So we'll go ahead and replace it with look action. And instead of move, we're going to call our new function called look. And now we don't need turn or look up, as these were handling the rotation behavior of the camera in response to the mouse. We now have this function that can handle it. Now, if we look at our turn and look up functions, we saw that all we did was call add controller yaw input, passing in the value, and add controller pitch input, passing in the value. That's all we need to do in our look function, as long as we can get those values from our input action. So from look, we need the value from the f input action value. Well, we can use value.get with an f vector 2d. So I'm going to make a const f vector 2d, and this one can be called look axis vector. And we'll initialize it just like we did in move. We'll get value.get, specifying a vector 2d. And all we need to do is call add controller pitch input. And for the pitch, we're looking up and down. We want that y-axis value from our input action. So we're going to get look axis vector dot y. And we can call add controller yaw input. And for this, we want the look axis vector dot x, as we're moving the mouse left and right if we want to change the yaw. And that's it. Now, if your game has some sort of checks in place in the code, you'll want to make those checks here. For example, later in the course, we'll check the action state and make sure that it's unoccupied. In other words, if it's not set to unoccupied, this enum constant, then we return, so we can't move. You can always add those types of checks in your callbacks. For example, my new move function can check the action state, see if it's not unoccupied. If it's not, return, and that'll prevent us from moving when we shouldn't be. So that takes care of move and look. Now we can go ahead and compile this and set our variables /context, movement action, and look action in the blueprint and test it out. So I'll go ahead and close out of the editor, saving all, and we'll compile and launch from here in Visual Studio. So launching the editor, we can open our asset editors. I don't have my character blueprint open, so I'm going to open it and set the values. We put them all in category input. So we have /context. That's our input mapping context called IMC/. So we're going to set that to IMC/. For movement action, we have IA movement. And for look action, we have IA looking. So setting those, we should now be able to press play, and I should be able to click in the viewport and move, and I can rotate and look around. And if I press W, I move forward. I can move back, left, and right. Now, if you're earlier on in the course and you haven't added animations yet, don't worry, we'll get to that. But we now have movement, and this is the most complicated part of the enhanced input system for the character. Now, later in the course, we add even more inputs aside from the move and turn axis mappings. So once you get to those points in the course, you're going to come back to this video at this point in time. Now, the rest of these inputs are action mappings. We see that jump is mapped to the space bar. Equip is mapped to the E key. Attack is mapped to the left mouse button, and dodge is mapped to the right mouse button. Now, these are all one-offs. We click a button or press a key, and something happens once. We can make input actions for each of these, and they can all be simple. They can just be Boolean input action types. So let's make jump, equip, attack, and dodge. So back to input, we'll make a new input action called IA jump. And we can open it and see that it's already set to bool. So we don't need to actually change this at all. Now, we're going to want a variable for this in C++, and we'll want to bind a function to it. Now, here's the cool thing about these simple Boolean input actions. We only want to do something when this input action is triggered, and we don't really care about the value of the bool. If it's being triggered, we want to jump. So back in our character header file, we can add a new input action variable. And this can be jump action. Now my character already has a jump function. It's overriding the jump function inherited from the character class. It's up here. It's a virtual override, and it takes 0 input parameters. Well, we can bind a function to an input action that takes no inputs, unlike these move and look functions that take the F input action value. We don't actually have to have a function take any inputs to bind to an input action. So all we need to do is come into setup player input component and bind the action. So once again, copying the line, we're going to change this to jump action, and we'll bind our jump function, which has 0 parameters. And that's it. So we can close the editor again, and we can compile and launch, but first we might as well go ahead and comment out the binding for the jump action, as we don't need it anymore. And back in the editor, we can open our asset editors, and we want our character, because searching the details panel for input, we want to fill in that jump action with our new IA jump input action that we just made. Now, we also need to add this to our input mapping context. So we'll go ahead and add a new mapping, selecting our IA jump, and we need to select a key. I'm just going to use the spacebar, and I'm not going to add any modifiers. So we can test this by pressing play and pressing the spacebar. In fact, I can use the console command show debug enhanced input. And we now see that IA looking is triggered when I move the mouse. IA movement is triggered when I use WASD, and we can see which of those values is true at any given point in time. And we can jump, and we see that spacebar triggers the jump input action. So now that we know that we can have a simple input action that takes a bool, and we can bind a callback to it that doesn't even take any inputs, then we can go ahead and add any inputs that we want to be fired off that don't really require any information. Jump doesn't require info, and the rest of the action mappings here in this project don't require information. We have an equip, attack, and a dodge. And these function callbacks that are bound to these action mappings are not actually functions that take inputs. They are void. In fact, let's go and look at them. E key pressed is a parameterless function, and so is attack and dodge. So it doesn't even matter what's in these functions. All we need to do is create input actions for each one and bind the functions to them. And then it's up to us to decide what happens in those functions. And you'll learn in this course how to implement these behaviors, but we're just going to bind these to some input actions. Let's make the input actions first. So back to my input folder, we'll make 3 more input actions. I'm going to go to input, input action, IA, and this one will be E key pressed. I'll have another one, and this one will be IA attack. And we'll have another one, and this will be IA dodge. Now I just need to add these to my input mapping context and choose keys for them. So we'll add another one. This one can be E key pressed, and we're going to map this to the E key. We'll have another mapping. This one will be attack, and we can map this to the left mouse button. And finally, we'll have another mapping called dodge, and I'll map this to the right mouse button. Now we just need variables for these in the character class and to bind function callbacks to these input actions. So I'm going to search for input action and find my other input actions and simply make more for each new input action that we created. So this one can be E key action. This next one can be attack action. And the next one can be dodge action. And since I already have callbacks for these, binding those callbacks to these actions will be quite simple. We'll just use the same line we've been copying and change the action we're passing in. For this one, we can do E key action, and our function callback is called E key pressed. Next, we can do our attack action, and the callback is called attack. And next, we can do the dodge action, and the function is called dodge. Now we don't need any of this old code. We can remove all of it. And now all that's left is to compile and set our action variables in the blueprint and test it out. So once again, closing down the editor, saving all, I'll go ahead and compile. And back here in the editor, we can set those new input actions on the character blueprint. So searching for input, here they are. We have E key action. We'll select our new IA E key pressed. For attack action, we have IA attack. For dodge action, we have IA dodge. Now we can save, and if we press play, I can left click. We already have movement and looking around, but for E key pressed, we have some functionality in that function for picking up items. So I can press E, and we put the weapon on our back right away. If I press it again, I'll pull it out. Attack works, dodge works, and of course we know that jump works. Now, why did we put the weapon on our back right away? Well, we can know if we use tilde show debug enhanced input and we press the E key. We'll see that as long as we're holding that E key down, it's triggered. In fact, if we continue holding it down, we'll keep putting that sword back on our back and pulling it out, because every time we press the E key, it's going to trigger that function call. And our function call is designed to first pick up a weapon, but if we call it again right after, well, then we'll put it on our back. So that can be taken care of by perhaps disabling input for a short period of time with a delay or a timer. We could even restrict it here in our input mapping context with triggers. For example, if we add a trigger, we can expand the dropdown and see that we have quite a few different ways to approve the triggering of this action. If we look at pulse, it says trigger that fires at an interval in seconds while input is actuated. This will kind of limit us from spamming the callback. If we select pulse and expand it, we have the option to trigger on start, which means we'll get our callback fired off right away, but the interval is set to 1 second. So we have to wait a whole second in between firing off, even if we're holding that key down. So let's see what happens if we go and try to pick up a weapon. It doesn't actually spam that callback. We have to wait a whole second before we can use that callback again. So if I hold it down, you'll see that it waits a second before actually triggering it off again. And you can obviously change that from 1 second for the interval to maybe 0.5 seconds. So these triggers are extremely useful for controlling this behavior. You don't have to go and make a timer in C++ or use a delay node in Blueprint. You can just add one of these triggers, and I encourage you, as you're making your projects, to just kind of look at all the triggers and the modifiers and see how you can use them to make your life easier when you're making your games. So now we've converted this project to use enhanced input instead of the old input system, which means we can actually go to project settings, into input, and remove these action mappings. We can hit the trash can icon and remove all of them, and it doesn't matter because we're not using them anymore. We're using the new enhanced input system, and all of our inputs are working, and it looks great. So hopefully these videos has demystified enhanced input for you. As you can see, it's not that complicated, and we have lots of new capabilities, and this can really expand what we can do as we're making games. So thank you so much for joining me for this, and I hope you have a lot of fun using enhanced input in your Unreal Engine projects. I'll see you soon.